Hello everyone, our topic is instance segmentation of buildings using key points. The building segmentation is an important task in the remote sensing community, which benefits for many applications such as urban planning and monitoring and land use management. Semantic segmentation is to assign each pixel with a label of building and non-building. But the purpose of instance segmentation is to separate different instances of buildings. Recently, convolutional neural network has been successfully applied for the building segmentation task. One is fully convolutional network for semantic segmentation. Another network is mask-RCN for the instance segmentation. However, when we zoom in the results, we found the results are not perfect. First is the geometric details of the buildings are lost, and the boundaries are also blurred. And we have observed that the buildings, such as man-made objects, have distinct corner points. These corner points can preserve the shape and structure of buildings. In this case, we propose a novel key point-based instance segmentation method, which first detects the key points and then group these key points to construct the semantic mask of the buildings. Then, this slide shows the flowchart of our method, which consists of three parts: CNN, RPN, and FCN. First, the CNN extracts the feature maps, and followed by regional proposal network (RPN), which slide over the feature maps to generate proposals. Then, by row align, then the local features for each proposal can be acquired. Finally, the FCN can predict the key point heat map. This is guided by end-to-end training, which consists of three parts to construct the final loss. First is a cost entropy loss for proposal classification, and second is a bounding box loss for proposal regression. The third is a modified focal loss for key point estimation. Then we extract the key point and group these key points in a pure geometric way. Since we are focused on individual buildings, so we create a dataset from the IGARSS dataset, and the spatial resolution is 7.5 centimeters, and the patch size is 500 tile pixels. We have 1,400 training patches. For the numbers of validation testing, they are 140. Here we show the intermediate results, which are overlaid on area imagery. First is a key point map, and second is a boundary map. For comparison, we select two methods. One is FCN8S, another is mask-RCN. They are the state-of-art methods for both semantic segmentation and instance segmentation. And we can clearly say that our proposed method outperforms the other two methods with respect to mask and boundary accuracy. For visual results, we can clearly see the shape of the buildings are better preserved in our proposed method than the other two methods, and our algorithm can also preserve the sharp boundary of the buildings. For the conclusion, firstly, we have proposed a new instance segmentation approach that obtains semantic mask of buildings based on key point detection. The second is the proposed method first detect the key points of the building and then polygonize them to generate a semantic segmentation mask with final semantic boundary. And from the results, our approach can preserve fine-grained boundary and geometric details of buildings. Thanks for listening.